tonight I'm very excited to be joined by Martin Traverso, co-founder and CTO of Starburst Data, and co-creator of Trino. Martin played a pivotal role in developing Trino while at Facebook, revolutionizing SQL analytics for fast interactive queries. Since then, Trino has been widely adopted by companies like Netflix, Amazon, and LinkedIn, powering data innovation across industries. Today at Starburst, Martin continues to lead the way in redefining how organizations access and analyze data at scale. Martin, great to have you here. Round of applause.
Hi, thank you, Peter. It's great to be here. We don't have microphones, so hopefully people in the back can hear. Yes?
Can you all hear us? Awesome. Yes, well, it's an absolute honor and a pleasure. First time in Australia?
First time in Australia, yeah.
Right.
Yeah, we spent some time in Melbourne. Last couple of days was great.
You had a coffee, right?
Lots of coffee.
Lots of coffee, great. So you're pretty well wired tonight, right?
Yes, yeah. I had only 2 today. So.
Awesome. So you've had an incredible journey in the data space. Could you give us a quick introduction to your background and sort of what led to you to co-create Trino?
Yeah, I started my career in early 2000s, and I worked at a few startups in consumer, enterprise, and I got involved in its data ecosystem, but mostly from a user perspective. I was one of the company I used to work for was one of the early adopters of Hadoop and MapReduce in around 2004, 2005. And then in another one of the companies I worked for, we started using Hive. So I kind of got exposure to that ecosystem and all the problems that exist in that ecosystem over the years. Then eventually I got hired at Facebook, and we saw an opportunity for improving things in that technology stack. I mean, Facebook was one of the biggest companies with data infrastructure, data warehouse. It was probably the largest data warehouse in the world at the time, and of course, it was at the forefront of all the the technology that allows you to analyze data at that scale, but also all the problems that come with that. So,
yeah, for sure. So, tell us a little bit about sort of what led to the creation of Trino at Facebook, because Facebook is a peculiar company. A lot of those Bay Area startups, you would think they're all in the cloud, but not the case, right? They're big, large on-prem data centers and lots of interesting, challenges to deal with, and dealing with sort of like Hive and all the rest. So tell us a little bit about how sort of Trino came to be.
Right. So Facebook had a warehouse that was 300 petabytes back in 2012, 13, and now it's a lot bigger, of course. And I know if you know the history, Hive came out of Facebook. They had this massive data set, and they need to enable their data engineers, data scientists to be able to analyze the data. Facebook is a company that prides itself of being a data-driven company. So they need access to that data. And obviously there was no technology that could satisfy that at the time. So they came out with Hive, but Hive had a lot of limitations. When I joined Facebook, people use Hive primarily as a primary tool for doing analytics. And this is for people that are sitting on their computer and their job is solely to go and look at data sets, analyze them, data engineering jobs, data analytics jobs. And they're sitting in front of Hive and writing a query, and the query takes half an hour. There was a data engineer that famously said within Facebook, they said, it is a good day when we can run 6 queries. So, so if you can imagine your job is to just analyze data, produce insights to run the business, and you're just sitting in front of the computer waiting for results to come back. So when I joined Facebook with a couple of friends, we joined the data infra team, and we said, well, there's there has to be a better way to do this. We knew the limitations of Hive, and we said we can build something better. There was another system that some people had built at the time that was trying to address that pain point, but it wasn't designed to scale. It was hitting the limits. It ran queries much faster than Hive, but it was very limited. It can only do very simplified queries like filters, aggregations, and that's it, no joins, for instance. So we said we can build a fully featured SQL engine at the scale that we need at Facebook, and that's what we ended up building.
Fascinating. Yeah, I can imagine like 6 queries a day, especially someone who's pretty well paid, Facebook engineer. That would be an incredible, waste of So, and so looking at Presto, and Trino and open sourcing it, what was kind of the thinking behind that? And did you envisage it rising, gaining so much popularity, and really enabling the whole, if you will, sort of like iceberg ecosystem because of that ability to have a query engine detached from the storage layer?
Yeah, when we joined Facebook, one of the things we said, and we talked to our VP at the time, we said we want to build this, but we want it to be open source. I personally didn't want to go and spend, building a query engine, a database takes years. It takes 5-10 years to get it to be really production solid and cover all the use cases. So I didn't want to go and spend that amount of time, and the project end up dying eventually, which is typically what happens at these companies. So we said we're going to make it open source, and of course it has a number of advantages. Making it open source, you get larger exposure to a larger set of use cases. You get help from other people that want to participate in the project and contribute code and improvements. And so that was kind of the premise. We said we're going to make it open source. We started working on it. Everything we did was with an eye towards making it open source. We use open source tools that were designed for that. For example, all the code was in GitHub from the beginning. It was a private repository in the beginning. We structured the code in a way that eventually we could open source it without a lot of dependencies that we had to extricate out of Facebook. And then a year later, it was a simple okay, press the button, and then it's open, and of course announcements and trying to get other people to join the project. So yeah, that was why we made open source. I didn't want to let it die somewhere in some company. And then after that, this is something that we hope for, but we can predict. We didn't have any real expectations that others in the industry would pick it up and it would become widespread and popular as it became eventually.
Yeah, it must have been a pretty proud moment to see sort of like the journey over so many years, because you did the initial commit, right?
I have the initial commit. It says initial commit.
Yeah, you're very famous already, but that is definitely a claim to fame. So over the years, especially looking back in the early days, what was the sort of key breakthrough that you saw with the Trino project? What sort of enabled it to, I guess, take on so much steam?
Yeah, there's one feature that I think it was the watershed moment for the project. So we had to make Trino work at Facebook, and that meant be able to query the Hive and Hadoop data warehouse at Facebook, which, even though Hive and Hadoop were open source, Facebook had forked those projects, and they had extended projects in incompatible ways. So that put us in an interesting position. We wanted Trino to be open source, but at the same time be able to talk to the internal technology at Facebook. So if we wanted it to be open source, we wanted to make it available for others to query open source Hadoop and open source Hive. So it's like we were thinking, well, how do we do that? And in retrospect, the obvious approach to that is to create an abstraction layer for the how do you access data, how do you access the underlying storage. So we introduced this connector APIs inside the engine. And we had one version of a connector that understood Hadoop and Hive from Facebook, and one for open source Apache Hadoop and Hive. And then we shipped the public version, the open source version with Trino, public Trino, and then we had our own internal deployment with our own private connector internally at Facebook. And that abstraction, that connector API, made it possible over the years to add connectors to a number of different data sources. Shortly after, there was another team. We have a friend in another team that built the. I mean, you have used Facebook. The news feed has a system underneath that serves, manages and serves all the stories, the stories that you see on the feed. It's a real-time system in memory, and they wanted to be able to do analytics over that storage. And they were about to embark in a project to implement a SQL engine on top of that storage. We said, hey, stop. We have this API. We'll show you how to implement the APIs. He spent 2 weeks prototyping, and then another 2 weeks deploying to production. So in a month, they had a full SQL engine on top of this custom data store. And then once people at the company saw that, they said, okay, I want to use it for this store and that store and that store. And there's a proliferation of use cases throughout the company. And then eventually others in the industry picked it up and added connectors for all sorts of backend systems, DBMSs, semi-structured data stores, streaming systems. So, now you look at it and it's like, well, obviously you want to be able to connect to those systems. At the time, like around 2015, that wasn't as obvious. And it was one of the features that made Trino popular around that.
Yeah, that must have been a awesome moment to sort of like newsfeed analytics, right? Facebook newsfeed analytics, huge. So oftentimes we hear Trino and Iceberg sort of paired up together. And what makes it such a great fit for lakehouse architectures?
Yeah, so if we look back in time, look at the days when we had the traditional data warehouse systems like Netezza, Teradata, Netezza a bit newer, but Teradata, like 40 years old. It's a fully featured data warehouse system with a SQL layer, table management, storage, transactions, security. When the industry moved to large-scale systems based on Hadoop and Hive, we lost all those nice things, all those features. People started taking advantage of the underlying distributed computation platform, but they had to custom code to analytics like Java, Scala, Python, everything from the ground up, and even a simple analysis of counting things is a big chore. It was a big project. With Trino, one of the things that I wouldn't say is unique to Trino is there was a movement around that time. There was Impala, Trino, Apache Drill. People were trying to bring back some of the features that everyone was missing from the data warehouse days into the Hadoop ecosystem. So we brought the SQL layer with Trino, but we still had underlying that there was a Hive table format which was very limited. It wasn't particularly powerful. For example, you can create tables, sure. You can insert into tables, but you cannot do it safely. If you had two queries inserting data into a Hive table, you get corruption. Like you don't know, one query may clobber the data from the other query. You'll never know. You end up with incorrect results in that table. If you want to evolve your table, there's no way to gracefully and gradually evolve the schema and the partitioning of your table. So you have to copy all that data into a new table. And when you're talking about petabytes of data, that's a lot of data movement, a lot of data copying, a lot of duplication. So what Iceberg did was solve all those problems. Yeah. And you can really update a table. You can insert a row delete a row in Hive in the underlying Hive table format. And around that time, the industry started moving towards more regulation around how you manage data. Like GDPR came along. There was a mandate, especially at Facebook, you need to be able to delete data for a user. And at Facebook, it was a very complicated project to do that because we had Hive. Others in the industry, like Netflix, they went and created Iceberg to be able to solve those problems. So Iceberg, in a way, brought back the data management layer of the old days of data warehouse systems to these data lake-based architectures. So with Trino and with Iceberg, you kind of get a pretty good pairing of capabilities.
Yeah, full sort of data warehouse experience, but with the ability to do a distributed,
at massive scale. Yeah.
Schema evolution, those sorts of things, time travel, all the good stuff. So this is designed to be a bit of an interactive session, so please do sort of think of any great questions. It's not every day we get Martin in the country, so it's first time, in fact. So please do put your hand up to ask questions. But oftentimes, in 1 second, we'll come back to you very shortly. Oftentimes we see Starburst talked about in sort of data mesh circles. Tell us a little bit about how Trino and Starburst are such a really good fit for data mesh.
Mm-hmm. Well, I mean, I was talking about the connector, our APIs inside Trino. I think that's the key. So having a Trino and Starburst as your single point of access to your data through those connectors makes it possible to abstract away, like where the data lives. You may have data that is on-prem, data that is in the cloud, data in different data silos. With Trino, you can query all that data, and as Michael was showing earlier, you can query all that data in a single query and bring it from different data sources, join it on the fly. Like the alternative to that is you have to go through all these ETL processes that can take a long time to even get going. Getting all the approvals, getting all the planning to take data from one place to another. It can take a lot of time, and that's time lost. It's an opportunity cost to be able to go and explore and figure out what you want to do with that data. So Trino with the connectors makes that much more possible, and makes it possible to be more agile, nimble about how you operate against that data.
Yeah, you can get access. It's discoverable. It's got all of the control over access policies and things like
exactly.
that. Yeah, governance and stuff that you'd want in a data mesh solution, right? Yeah. Please, got a question for us?
I'm curious. So from 6 queries per day, where did you get to in the first phase, kind of, and how was that journey? Like, may not have been easy.
So Trino out of the gate. So it took us from the first commit to getting the system in production 6 months. We had at the beginning it was fairly limited. You can do filters, simple joins, aggregations, but just that alone allowed people to run queries that would take, I don't know, half an hour to an hour in a few seconds, maybe a minute. It's actually pretty powerful. There's one interesting story. We just deployed the system to production, and we were demoing it to our manager. We're in a meeting where, hey, let me show you the query. It was a very simple query that, I don't know, just counting things or summing things, and query came back like instantaneously over a massive amount of data. Then we went back to our desk and we're trying to interact with the cluster, and it's like nothing works. Like, we can't talk to the cluster. What's going on? So we talked to the network engineering people, and they said, yeah, we had to shut down your cluster because you caused a brownout on the network. It was so the system was so fast and efficient that it could pull more data than any other system that we have at Facebook. And we end up uncovering a deficiency in the network architecture that no other system had been able to do. So not even Hive running at the massive scale was able to put that much load in terms of how much data in so little time was being pulled from the network.
Awesome. Sounds cool.
Sort of a follow-up question to that with the networking bottlenecks that you suggested there is if you had, say, a client who wants to integrate Starburst and they had something like an express route with a bottleneck in the bandwidth speed, how would you handle?
Are you talking about Starburst talking to a backend system
Yes,
with
on-prem.
Well, I mean, it depends on what you're talking to. There are some data sources that are inherently limited. For example, if you're talking to a MySQL, the only way to talk to MySQL is through, say, a JDBC driver or something like that. It's a single pipe. You can't really parallelize the access, so you're gonna be limited by that. For other connectors, like for example, we have a connector for Oracle. We can take advantage of some capabilities in Oracle to read in parallel from Oracle. So you're still limited by whatever your Oracle is capable of doing, but at least you can parallelize across. If you're talking to other systems like Elasticsearch, now Elasticsearch is a cluster of machines. We can do massive parallel reads from those systems. So you can go as fast as you can parallelize across those systems. And then, yeah, it really depends on what you're talking to. If you hit, there are some cases where you hit those limitations, those bandwidth or parallelism limitations. What we generally recommend is you have that as a way to access data in those systems, and you can use it to explore, to kind of get a sense of maybe experiment, like join this data with that data, see if there's value in bringing that data together. And then once you prove that, then you can bring the data into the data lake. And we have at Starburst, or in the Starburst product, we have a mechanism that can take a table, kind of replicate into the data lake, and then transparently you write a query and against this table and transparently redirects to the replica in the data lake. So you get the performance of the data lake with the perception that you're talking to the underlying data store.
And how would you keep this in sync? So the original gets updated. How do you then keep the data lake?
Right. Yeah. So you set up that process for replication. You could think of it as a lightweight ETL between the original table and the table in the data lake. Now that's only necessary if that becomes a bottleneck. Like you do it only if you have to. Like if you're pulling small data or you're not sensitive to latencies, then it might be okay to just read from the remote system and get the live copy.
Question over there.
I think it's more of a philosophical question. Mm-hmm. So you have been working on a lot of cool open source projects. Of course, Starburst, I don't think it's open source. Correct me if I'm wrong. How do you look at this balance? Because as a young guy in tech, I look at open source as being democratized and it's going to give power to everybody. And you told another aspect where solutions are fast, but the big tech doesn't look at open source the same way. Mm-hmm. I've been using Firefox and I'm suffering a lot, but just a philosophical thought of how do you sort of like look at this and where you will like sort of see yourself today?
Well, so Trino is a query engine, and if you think about it, it's pretty bare bones. You have the query engine. You have a few connectors. Some are better than others. You have the connector for Iceberg and Hive, and a couple others that are more well supported within the community. People are investing more time in those, but it really lacks any of the enterprise features, like how do you manage permissions, access control, policies, metadata. For example, there's no metastore. There's no catalog associated with it. How do you even deploy your cluster? How do you manage the deployment, scale it up? As Michael was showing earlier, at Starburst we have the ability to, with a click of a button, you get a cluster, you can run it. When you're not using it, it scales down to 0. So building all that infrastructure is a lot of work, and most enterprises don't want to do that, and it's actually not in their best interest to do that. You have a business to run. Yeah, you don't want to be building software that others can do for you and do it better. So I think that's kind of where the distinction is. The core technology is open. It allows people that are very tech savvy, they can go and run it, they can experiment with it. But in an enterprise setting, you need more than that. You need all the bells and whistles, and that's where Starburst provides value.
And so what are some of the most innovative ways that you're seeing sort of Trino and Iceberg being used out there in the market?
Yeah, so I mean, I talked about how we use Trino at Facebook for data analytics. It's very, very typical. People deploy it and they have a massive data warehouse. They are powering dashboards. They're powering data transformation processes, ad hoc interactive analytics. One of the things we've been seeing lately is people building applications, potentially user-facing applications that need to be able to take these massive amounts of data and produce different slicing and dicing and presentations of that data, and build entire applications on top of this type of system. Historically, they would maybe take a MySQL or a Postgres and do that on top of those databases, but those, of course, cannot scale to the amounts of data and to the, as Michael was saying, potential concurrency. So we're seeing people building what we call data applications on top of Trino with Iceberg. Yeah, I think it's a pretty innovative set of use cases, and something that most people in the past few years haven't thought about doing on these data lake-based technologies.
Yeah, awesome. And AI-driven applications and agents are becoming more prominent. How do you see Trino playing a role in enabling AI applications?
Yeah, well, to do AI, you need data. You need access to data. So I think Trino is in the sweet spot of that ecosystem. If you look at the conversation over the past couple of years around AI has been mostly around unstructured data. The LLMs are trained on the web, right? It's web pages, documents, and so on. People have been talking about over the last year or so RAG workflows, where you take data that is part of your enterprise and mash it together with what the LLMs can do to be able to answer specific questions about your domain data. But that's still all around unstructured data. It's documents, images, PDFs, and so on. There's an entire world of semi-structured and structured data that enterprises deal with. The data warehouses, all the tables, a bunch of JSON data that people manage. So you need to, if you want to bring all that together into these AI frameworks and AI workflows, you need a way to collect the data from different systems in one place. And with Trino and the connectors, that's kind of I think perfect fit for that.
Yeah, because I guess the way that you'd come up with one of these AI applications or agentic workflows is you think about the sort of data that you require to fetch, right? And then, Trino is there to help you to just get at it nice and quickly rather than, do these massive ETL sort of jobs or projects that take 5 months, or so years, months or, and the like. So fascinating. Keep those questions coming. Yep.
Thanks, Mike. We're predominantly Databricks. And I just wanted to get your view on maybe parity, where the blind spots that we're seeing with the vendor lock-in. motivate?
Yeah, I think one of the key differentiations between Starburst and Databricks is a cloud product. One of the things we see a lot, and I think we're talking about this yesterday, there are companies that have a lot of data on-prem. They are on a journey to migrate to the cloud. We see companies that are actually in the cloud and migrating back to on-prem. And there are companies that have a mix and they don't ever plan to be in one or the other because of regulatory reasons. And they may need to keep some data sets on-prem and they want to still take advantage of the capabilities of cloud. So they have a mix of data sets, mix of workloads. One of the things that Starburst can do is it can deploy and bring those two environments together. So yeah, I think it's if your company's running into those type of issues, that's something that you should take a look at, something that Starburst can help with.
Yeah.
Yeah. The choice of tech, right? So
Yeah.
Databricks, Delta Lake, Woody. Is it safe to say that?
I mean, I think so. So Hoodie is a very niche. It has one feature that made it interesting at some point, which has to do with how you ingest data into the Hoodie table format. But that's something that Delta Lake and Iceberg are catching up to. But then if you look at Databricks acquired Tabular last year, that makes it very clear that they are going to be investing in Iceberg. Iceberg has a larger community. It's an open format. Delta Lake is open, but not really. Still, the specifications still driven by Databricks. So yeah, I think Iceberg has implicitly and explicitly in many ways has won the formal one. We do, yeah, we do. We have some engineers that are involved in that community. Trino, because it's designed to work with Iceberg, we follow all the developments very closely, and we're even engaging with the community to drive some future developments. Yeah.
Just another tech. So I was intrigued about Starburst. The end-to-end encryption. How do you
End-to-end encryption of data. Well, there's encryption at different layers. So, for example, the client talking to a server is an encrypted connection. The coordinator and the workers talk to each other through encrypted connections. When you're talking to, when Trino and Starburst talk to, say, S3, they are obviously using SSL, so it's all encrypted. And then if you have data on S3 that is encrypted, you have encryption at rest. So there's no end-to-end in that the data is completely opaque to the engine. The engine has to be able to read the data decrypted to process it. But all the hops have some level of encryption. Right. Yeah. Yeah, I mean that would be. I think it's physically impossible to do that because if you're doing, I don't know, aggregations or any sort of understanding. Say you want to run a regular expression over your data, you need to be able to see the unencrypted data. There's no way to run a regex on encrypted data, right? So, but you want all the hops to have proper encryption and security, which is what we do.
Yeah, definitely. So, virtual to a private cloud, right? So it's their own. I've yet to.
Yeah.
Awesome. Everyone? Yeah.
To complement what you were saying, do you have a feature? Is there a column that they
Yeah, we have. Michael was talking about that earlier. Where is? Yeah. Do you wanna?
I mean, there's a variety of different, I guess, like regulatory reasons for storing data in specific ways. So just like encryption, let's say you are enforced to store data encrypted at rest, and you might use a tool that has plugins available for Starburst. That means that when a user requests data, that they do have the ability to decrypt and see the raw data. They would leverage that plugin to be able to decrypt using envelope encryption. So they would then see that data. That could be policy-based. So certain groups of users get access to the keys to decrypt that column. Other users just see the encrypted column because that's what's coming out of the storage layer, and then Starburst is operating on top of that encrypted data. So in their case, regex doesn't work because regex wouldn't work on that encrypted content. So there's various different, I guess it depends on your security framework and what you need to do with data at rest.
Awesome. Up the back, Piotr.
This is a bit of a different question. I'm an engineer myself. I don't often talk to people that have developed a project that have some favor in the community. I was wondering, to tell more about, maybe you mentioned this already, but what type of position were you on when you started working on a project? Was I looking for something to like, where were you are in your career? What were you thinking? Did someone tell you to build Trino? Did you just rogue it? Did you just go rebel and then just like, I need this in my project? I'm going to build it.
Yeah, I think I was in it was a very fortunate situation. So the VP of Eng at Facebook was my manager at a company before that. So he knew me, and it was a combination of things. So I joined Facebook. Some of the senior engineers in the data infra team had already left. So they didn't have any senior technical people there. So he said, "Hey, you join Facebook and you go through this process, like a 6-week process where you get to try different teams, do tasks for different teams to try to pick what interests you, and then teams try to sell you on, hey, come work with us." So he said, I know you have to go through the bootcamp process, but I want you in data infrastructure. And then we started talking to the data infra people, and we're trying to figure out what can we do here. And then we identified that problem. And he said, when we said, hey, we can solve this, we can do something around this, it seems to be a big pain point, he said, yeah, go for it. You have the rope to do it. So.
You always knew what you wanted to build?
No. I was saying before, I had seen the pain points from the user side. I had used Hadoop. I had to write MapReduce jobs and manage them myself. I had used Hive at a company before I joined Facebook, and we had the issue that we run a query and it takes like an hour to get results.
You're frustrated.
We were frustrated, and we saw that people were frustrated at Facebook too. So we said, okay, this is a good opportunity. Plus, I was very interested. I mean, I had worked on large-scale distributed systems. I'm a bit of a programming language geek and compilers and all that. So it's like, okay, this seems like a very interesting thing to work on. I didn't know anything about how a database worked at the time, so I kind of had to figure it out on the spot, on the job. But yeah, I think I was fortunate. I mean, I wish everyone had the same opportunities I had at the moment, but.
Model data, but
Do you have any ideas, Michael?
Sorry, can you repeat the question? Maybe I
how do you convince a startup that's got multimodal data, right, to get started on a data lake architecture?
Multimodal? What does that mean?
It's just like from the database content. And they're not too afraid to like data or like schema inference, like all the package that comes with it. Use cases for big companies, obviously. Companies profit from it as well, but they really struggle to have all of this connected face to face.
Well, so one thing, and maybe you can complement there, but so one of the things with Starburst, it's actually pretty low friction to do that. So if you have data in S3, in Object Store, even if it's not, you don't have schemas, you don't have glue, you're not using glue for your catalogs, you don't have any like higher level descriptions of what your tables comes and so on. It's very, very low friction. You can just go click a button, create a cluster, create a connection to your S3 storage, and then you can say infer the schema for the table, and it will create a catalog for you. And then you can try it. You can very quickly. I know how long does it take to go through that process? Like
for small data sets, it's fast.
Yeah.
Yeah. You'd be running in minutes if you knew what you were clicking. There's YouTube videos that probably have recordings.
Yeah, so it's very, very easy to try, and then you can maybe immediately start seeing benefits and getting value out of it.
Yeah, and I think the other thing that's complementary to that is that Iceberg looks and feels like a data warehouse. So a lot of the operations that you do on a data warehouse, you're doing with Iceberg. So if you wanted to create new data and try experimenting with something that's new that you haven't seen yet, you can try doing that. And it's just writing back to object storage. You can use your S3 browser to navigate the folder directory structure, see the partitions, see the layout, see the metadata. The metadata is in plain text as JSON files. So you can take a look and start to understand how that data structure looks like under the hood. It's all open, so you can read it with other tools as well. So you can get your proprietary tools on your laptop and look at how that data is.
Yeah, just follow up.
Yeah. What are some of the biggest challenge
I think the AI ecosystem is both a challenge and an opportunity. I think getting the product and the tools to better fit that ecosystem. Every company is thinking about AI these days, right? Everyone's trying to figure out what AI can do for their business and where AI fits in their workflows in their business. So for us is having all the features that enable the companies to do that exploration and figure out where AI fits. It's going to be a big opportunity, and we are starting to invest in many of those features.
You had one?
Yeah, well, similarly, where do you see your year 2030?
Sorry, say.
Where do you see yourself being 2030?
Where I see myself being.
Of course, Trino 2.0 or whatever you call it then.
You haven't done your 10-year plan.
Yeah, I know. I don't plan that far ahead.
Yeah.
Hopefully retired.
Yeah, on a yacht somewhere, perhaps.
No, so one thing is like, I mean, I've been working on Trino for 13 years, and there's still so many things to do. So many things. Like, we're now embarking on a project to revamp the optimizer, for instance. It's like all these ideas I've been thinking about for the last 7 years that we never got the chance to do. So it's like there's always something else that we can improve, we can make better. There's, we can geek out on all the technical details and things that can be improved. Like there's, I don't know, everything from optimizer to execution to new paradigms, new language features. Like those are things I never stop thinking about. So I mean, even after hopefully eventually retire, I'll still be thinking about those things and working those things. So.
So just to wrap up, Martin, you mentioned a few things because they both asked you what was next, what's on the roadmap. You talked about some query optimizations that's coming. Take us through some of the other things that you've got on the roadmap.
Yeah, so I was talking about AI. So we're working on a number of AI features to complement. So I talked about how Starburst and Trino being the single point of access to all your data, and that can help feed your AI workflows, AI processes. We're building features also to bring those AI workflows into the SQL engine. So through SQL queries, you can interact with LLMs. You can do similarity searches with vector embeddings, combine it with full text search. So you don't have to leave the SQL ecosystem and simplify the integration with all the AI tools, all within the product. So that's one of the big areas we're investing in. And then of course at the kind of deep inside the engine, improving performance, the optimizer, where kind of building the next generation of optimizations, the execution engine. There are a number of optimizations that we have been talking about for years, and now we're getting to implement, taking advantage of columnar formats and evaluation and better implementation of the operators. So all of those things will hopefully make the engine like a few factors faster for a number of workloads.
A few factors. Pretty impressive, right? Awesome. Well, massive round of applause from our team. Thanks so much for answering all these questions, surviving the grilling. These guys, they're unrelenting, aren't they? But no, thank you. Cheers. Really appreciate it.
Yeah, thanks for having me.